Pop quiz. Which of these is not a real kind of wind? Trade winds, polar easterlies, polar westerlies, prevailing westerlies. Stay tuned for the end of this video to find out. Welcome to Science with Savannah, age 7.
It lifts kites, generates electricity, and moves weather around the planet. Today, we're talking about wind. But where does wind come from?
Wind is caused by differences in air pressure. Nature likes things to be in balance, so air will always move to an area of high pressure to an area of low pressure. If we fill up a balloon, the air inside is under pressure. As soon as we open the balloon, the air rushes out until the pressure is the same.
So now you can blow it up, and then you can just let it go. And that balance is called equilibrium. But does that mean that wind comes out of like a giant mountain-sized balloon somewhere?
Of course not. You could say that wind comes from the sun. When air is warm, the atoms and molecules move faster and spread out. This makes the air less dense, so it rises. That's why steam coming off of a pot of blowing water always goes upward. When air is colder, the molecules get slower and closer together. Colder air is more dense, so it sinks.
Mm-hmm. Now the sun shining on the earth warms the air, but it doesn't happen evenly. The sun hits different parts of the earth at different angles, and the 29% of the earth that's land warms up faster than the 71% of it that's water. This means that some areas will have cold, dense air, and some areas will have warm, less dense air. The areas of cold, dense air are high pressure.
When the warmer air rises, it leaves an area of low pressure behind. Now we're getting to the part where wind happens. Air moves from the high pressure areas to low pressure areas. The bigger the difference between the pressures, the faster the air will move from the high to the low pressure.
Okay, blow up one a lot and blow up the other one a little bit. I have asthma, so you're on your own on this. That little one. Okay, good. Now, the air in the small balloon is under less pressure than the air in the big balloon. So the air in the big balloon under higher pressure will come out faster. 3, 2, 1. Well, if you weren't holding the neck, it would come out faster. And that rush of air that we feel is the wind.
Global winds are created by both the difference in temperature between the equator and the poles, and the spin of the Earth, called the Coriolis effect.
Coriolis effect.
Coriolis effect.
Good. Wind speed is measured with a device called an anemometer. Anemometer comes from the Greek words anemo for wind and metron to measure.
And you can build your own.
Building your own anemometer is fun and fast. Maybe not that fast. You need 5 paper cups. In one of them, poke holes equidistant around the top. Thread through 2 plastic straws. In the remaining 4 cups, Poke 2 holes each that are off-center and thread them onto the straws. Poke a hole in the bottom of the center cup and put the eraser end of a pencil in there. Let the adult helper put a pin or a needle through the 2 straws and into the eraser. Now blow into your anemometer and see it work.
The speed of wind is measured in knots, which is also how ships measure their speed. Admittedly, our anemometer doesn't actually tell us the wind speed, but it does help us see how fast the wind is blowing. Wind direction is given by the direction from which the wind comes. So when you say it's a south wind, that means it's coming from the south and going north.
These are many names of wind. Short bursts of wind moving at high speeds are known as gusts. Wind can also be known as a breeze, gale, storm, or hurricane, depending on how fast it's moving. Strong, straight winds with no rain is called a windstorm.
When you watch weather reports, you might hear about the jet stream. That's a fast-moving ribbon of air between 2 air masses with very different temperatures. The jet streams always move from west to east because of the Earth's rotation.
Warm winds blowing toward the equator are called trade winds. Trade winds are always blowing and are always warm.
The wind is useful in many ways. The wind dries up soggy, wet areas, taking the water that doesn't absorb into the ground back up into the atmosphere to become rain somewhere else.
The wind also plays an important role in helping plants reproduce by carrying seeds to different parts of the ground to take root and grow, and by carrying pollen from one plant to another so fruits, vegetables, and flowers can form.
We also use wind to help make electricity. A windmill's blades are connected to a generator. As it turns, it generates electricity.
Despite what some people say, windmills don't slow down the wind. They look better than smoke from coal-burning power plants. And like other green energy, they use batteries to make sure you have electricity even when the wind is low.
You tell them, Savannah. And now it's time for the fact fire. The fastest winds on Earth occur inside tornadoes, where wind speeds can reach 250 miles per hour, or 217 knots.
Meteorologists use
Barometers
to measure air pressure. Barometers can tell us if the air pressure is dropping or rising.
Other planets have wind too. Neptune has the highest sustained wind speed in our solar system at 1,300 miles an hour, which is 11,029 knots. It's going to be 1,129 knots.
A solar wind is a stream of charged particles that flows from the sun.
Good job. So what did we learn today? What is wind?
It's something that rises from high pressure to low.
Oh, good. And that results from the Earth heating unevenly from the sun.
The answer to today's pop quiz question, which of these is not a real kind of wind? Trick question, they're all real kinds of wind. In fact, prevailing westerlies have the greatest effect on the weather in the US and Canada. I admit it wasn't intended to be a trick question. I did something wrong in the research. But a good scientist should always be willing to review their original position when new facts come to light.
What other kind of sciencey questions could we be asking?
How fast is the air above us, or slow? How fast or slow is the one down here with us?
Okay, so like, how does the wind speed in the upper atmosphere compare to the wind at ground level?
Yeah.
That's a good question. Maybe we'll get to that next time on Science with Savannah.
Age 7.
That's right.
Yes, we are.
Stand up, please.
Yes, we are.
Wait a continuity error.
Okay. I can barely
Yeah,
do it.
I have asthma. You're on your own.